Hello and welcome to FPGA Design for Embedded Systems. In this video you will learn how to build bigger designs using modular design techniques, use of loops in VHDL, and how to use generate statements to make copies of circuits. Many tools are provided in VHDL to make modular designs, including component instantiations, looping, generate blocks, tasks, and functions. In a previous lecture, we learned how to instantiate my lower OR block into the upper level. So my instance 1 includes the component of my lower OR mapped A to A upper, B to B upper, and Z to Z upper. And in this case, we could make multiple instances, instance 1, instance 2, instance n. In the case of our adder, we have our component add4, and if we wanted to make an adder 16, we would use 4 instances of our add4. Add4 U1 would be mapped to bits 3 down to 0 for A, B, C, and some. And all the way out to our unit 4, which would be mapped to the upper bits, bits A 15 down to 12, B 15 down to 12, and some 15 down to 12. Looping in VHDL. There are several looping constructs in VHDL, including while and for. The for loop statement is written and behaves just like it does in C, as is the while loop. The while loop executes a statement or block of statements until a condition like less than or equals, so that the when compare exits the loop. In this case, we have an example in our architecture of a while loop. When I is less than or equal to 8, perform the loop. If B equals 1, then Z gets A, end if. And here's our loop counter. I gets I plus 1. So when I increments and is less than 8, we will end the while loop. The generate statement in VHDL, although loops can be used to generate data or test patterns, a common use of loops for synthesis is a replication of identical circuits within the generate blocks. The generate and generate block specifies an object to be repeated. The index variable of a for loop sets the number of elements to generate. Here we have our generate statement. For I in 0 to 7, generate x out of I gets A in of I XORed with B in of I. So in this case, our x out 0 bit gets A in 0 bit XORed with B in 0 bit. Bit 1, bit 2 on up to bit 7. So we're building an 8-bit bus, x out of A in of I XORed with B in of I. In this video, you've learned how to build bigger designs using modular design techniques, use of loops in VHDL, and how to use the generate statement to create copies of circuits.